Okay, number 12. It's false that no incendiary devices are contraptions that misfire. Therefore, some incendiary devices are not contraptions that misfire. So first things first, find the conclusion and the premise. Lucky for us, we've got this nice conclusion indicator here with therefore. So I know what my conclusion is, I know what the premise is. And so now I want to identify my subject and predicate terms. So one term is incendiary devices. So let's just go ahead and we'll do I. We'll use I for incendiary devices. And then the predicate term is contraptions that misfire. So we'll just go ahead and use C. Contraptions that misfire. So now what I do is I use I and C to translate this argument into symbolic form. Makes it much easier to work with. And I see right away I've got this phrase, it is false that on my premise. And I do not like that phrase. It's really difficult to work with Venn diagrams using that phrase until I get to this kind of next level thinking about Venn diagrams. So what I'm going to do is I'm going to use the rule of contradiction from either the modern or the traditional square. It applies to both. And I'm going to get rid of this phrase, it is false that, by discovering or creating a sentence that I know would have to be true when it's false that no incendiary devices or contraptions that misfire. I know if you give me an E claim and tell me that it's false, by the rule of contradiction, the corresponding I claim would have to be true. So some incendiary devices are contraptions that misfire. Therefore, the conclusion says, some incendiary devices are not contraptions that misfire. Okay, so now when I evaluate this argument, I know that when it is false that no incendiary devices are contraptions that misfire, when it is true that that's false, this statement would be true. So what I want to know is, if this statement does turn out to be true, would that mean that that statement would also have to be true? Because if it is, if it does mean that, then it's a valid argument. So I'm going to create my little Venn diagram here. This is going to be my incendiary devices circle, and this is going to be my contraptions that misfire. And I have to diagram in just the premise. Never go anywhere near that conclusion when you're marking a Venn diagram. And I ask myself, what does it look like if it's true that some I are C? Well, that would mean that there would have to be at least one I there, because it's this area 2 where the circles overlap. So anything in 2 is both an I and a C. So I've just shown you that some I are C. Now, the question I have is, all right, when this statement is true, does this statement also have to be true? So I look at my Venn diagram. Do you see the statement some I are not C? And I would say no. Maybe there's something over here in 1, and if there is, then that would be an example of an I that's not a C. But I don't know if there's anything in 1. The only thing I know is what the premise tells me, and that's that some I are C. So there is an I that's a C here in area 2, but I don't see anything here yet in area 1. So based on this information, I don't know whether the conclusion is true or false. I'd have to have more information. And that's what makes the argument invalid.